And let's start.
Okay, thank you. So, yeah, warm welcome. Hello, everybody. Today, I'd like to talk about, as already mentioned, driving efficiency. So, I want to share a spotlight at the devils that is in the details when building and developing the CI/CD processes. But first, let me introduce myself. I'm Maciej Rutkowski. I'm currently working as a DevSecOps engineer at Volvo Group, and I'm not from this famous Polish detective family, so at the beginning, if you're familiar with. And during the presentation, I'll be asking some questions. So for the answers, for somebody who want to answer the question, there will be some prizes, gadgets, and so on. So please bear with me. And when I say Volvo, what is the first things that come to your mind? Cars, of course. But to your surprise, Volvo Cars is a separate company, that Volvo Group for now. And Volvo Group is responsible for delivering maybe all of your clothes that you're buying in shops, or all of your food that is on the table. Maybe you are commuting to the Kraków with Volvo vehicles, because as Volvo Group, we develop trucks, buses, combustion engines, as well as parts for boats and construction machines. So, yeah, we deal with a lot of heavy stuff. I'm currently working in Product Center project, and it is a lifecycle management platform for engines and parts of the boats. So we basically deal with the engine when it's manufactured, then shipped to the customer, mounted in the boat, and then serviced and scrapped at the end. So many of you answered this question. I don't know if I have so many gadgets, but okay. Let's dive into the agenda of today's presentation. And first question is, what do we even want to optimize? Then we get some overview of Azure Pipelines agent and GitHub Runner, specification, possibilities, and limitations. So some dry config, just to have the fundamentals ready and address some of those. Then, based on a case study, we'll go into the next topics, which is reducing technical debt when it comes to VM images, templating our workflows, locking our dependencies, and caching solutions. So, what do we even want to optimize in such processes? I would like to look at CI/CD builds, workflows, as a whole product. So it needs to be architectured, developed, then maintained, fixed, and enhanced in an end-to-end way. So based on this approach, I've come with 3 key components that I would like to optimize. First and foremost, of course, money. So the money that is spent on a salary, for example, for us to develop such solutions, and then for hours spent on fixing poorly designed workflows, as well as running our builds on automation servers. Of course, we need to run our builds somewhere, and we don't want a heavy bill on top of our infrastructure bill at the end of the month. Then we'll focus on time. So, as already said, the time we are developing our pipelines, and as well the time to market. So our CI/CD processes should resolve a time to market for time for developing our solution to the market, and not make it longer. And the third, but not least important factor is code. We want to have as less as possible repeatable the same code in our repositories, which is prone for errors, typos, and so on, and as well reduce the technical debt, as automation solutions are updating from day to day, and something that is currently on top may be obsolete in 1 year. Okay, so what are the hosted options for Azure Pipeline agents? We have a self-hosted, let's say OG ones, virtual machine scale set agents, and Microsoft hosted agents. Who is using self-hosted agents? Okay, I see some hands. So you basically know what you're dealing with. You need to set up your own VM, then download your agent for Azure Pipelines, for example, or GitHub runners, and maintain it, download all of the toolkits, patch it, configure it, deal with security and networking stuff. And also, such a VM is running 24/7, so when there is no build, we pay for our infrastructure as well. Of course, we can switch it off and on, but then if we are running our builds in different time zones, it's hard to develop such solution. The hybrid approach would be to use the Azure Virtual Machine scale set, which is basically still a VM that you'll need to take care of, but it can scale horizontally. So for example, when there is no job running, it scales down to 0, and then as your jobs start to run, it can go up in the resources. And then the third option, who is using scale set here? Okay, I see some hands as well. And third option, Microsoft hosted agents as well as GitHub hosted runners. Who is using those here? Some here hands as well. Okay, so yeah, no need to deal with overhead configuration and so on, but there comes some possibilities and of course limitation with those approaches. But what are those limitations? First of foremost, hardware. Images for Windows and Ubuntu running 14 gigs of storage, 7 gigabytes of RAM, and 2 CPUs. macOS is a little more flexible, but it's not that common. 14 gigabytes of RAM, memory, storage, and 3 CPUs, and all of those are running on VM DS2 standard machines. And limitation and pricing. When it comes to limitation, self-hosted agents come with a pre-installed set of software. So we have a toolkit that we are working with and needs to be suitable in one way or another, which means that we can't install on top of software before or after our run, only during the pipeline run, which might be limitation for some specific tech stack. Another limitation that we already covered is this hardware thing. So we have 10 gigabytes for source and build outputs that might be not suitable for every big solution. And also the networking limitation. Can't remotely connect to our agent and can join agent to internal corporate network. It depends on the environment you're working with and the project. You might have some issues here as well. When it comes to pricing, $40 a month by one self-hosted agent. So that is pretty clear. When it comes to GitHub hosted runners, we have a little bit difference when it comes to where are you hosting and running your actions from. So for public repository, we have a little bit more elasticity. So for example, for Windows Ubuntu images, for CPUs, 16 gigs of memory and 14 gigs of storage, but for private repos, it will be 7 gigabytes memory, RAM, 14 gigabytes of storage, and 2 CPUs. When it comes to hardware running those builds, so for public repos, it is standard D4 VM for GitHub and for Ubuntu and Windows, and for private ones, it's DS2 VM from Azure. So basically, under the hood, all of it is on Azure VM. At the beginning of using such an agent, you'll have a set of minutes that you can work with, and with it comes a minute multiplier. So basically, 1 minute running Linux will be covered to 1 minute from your limit, but then Windows will be 2 times minute multiplier. So for each minute, you'll get 2 minutes of your limit. And here is the pricing. I think we won't get into that deep. Of course, Linux to CPUs is least expensive. Now, let's address some networking limitations. How we can manage, provision, and update our resources from such agents in our resource groups, subscriptions, and so on. So we have a few ways we are able to do it. For example, manage identities, workflow in entity federation, and as here shown, service principal. So how such service principal can work? Just to simply create a service principal in your Azure subscription, then assign it some roles to be able to provision your resources, connect to Azure Resource Manager service connection, and then in pipeline you can specify the service connection and provision and deploy to your infrastructure on Azure. But it won't cover all of the scenarios, and sometimes you'll need to bypass this firewall. You'll need to connect to your Key Vault, to your storage, for example, to retrieve a SAS token and so on. So Azure is posting weekly IP ranges of agents that are available in each zone, but we won't be updating each of the week all of the ranges for all of the agents in the in your zone, and because it's time consuming, it makes no sense, and also it is potentially a security threat for our projects. But if you really need such solution, you can just get a public IP of a agent itself with a simple script, then add it to your firewall, to your network rules. But here, if you're running such a task, please be careful and always set the condition to remove it at the end of your pipeline, to just not let anybody else connect to your resources after that, even if they don't have your service principal in place. Okay, as we already covered some fundamentals, some dry stuff, let's get into the real world. Let's imagine this case study. We are migrating one of our projects in the company to Azure DevOps automation platform or GitHub runners, whatever you want to call it. For now, we will be working with Azure DevOps, but the idea is pretty similar. They have a .NET application that they want to migrate their pipelines to, and they came up with a simple CI build. But they are not pretty happy with the result. It fails often, it downloads different dependencies each time, and the process is not that efficient as they want it to be. You as a DevOps specialist are asked to audit such a pipeline, make it more robust and efficient, and we'll need to keep in mind that they're dealing with more than one application, so such a solution will be applicable to many apps at the end. Okay, are you more or less familiar with the Azure pipelines or GitHub runners, GitHub pipelines? Okay, so basically the overview is pretty similar. We'll just use a task that are named a little bit different than actions, but at the beginning we have a VM image that we are using, then we define the set of variables, and we have such structure. We get stages, jobs, and steps, and tasks. So each of the tasks is at the beginning restore, then build our solution, test the solution, archive files, and publish build artifact at the end. So let's start small. The first thing, of course, is to choose the right VM image. For most of the builds, we'll use Ubuntu, of course, as it is more lightweight, probably more secure, spin up faster. But there are some scenarios that you will probably use the Windows one as you're running your VS builds, VS tests, or maybe some SQL scripts to your database. But then comes the version. And the first things that we can do just to reduce our technical debt at the first step is to use the latest version. We don't want to get stuck in the 2019 versions. Just get the latest minor bumps with the versions on our agents, with the toolkit that we are working with. So this way, we are not dealing with the configuration overhead after all. Great. As we have this ready, let's focus on another step, which is our variables. So what we can do if we will be dealing with multiple applications is to move this set of variables to another file, which will specify each of the variables for a group for each of the apps. So we do it simply just by creating template with a variables template and specify the variable group. And another question to you. What is wrong on this variable highlighted? Also, it's not that different, but I'll get this as an answer. Some more answers? Sorry? Yeah, exactly. So during the runs on our hosted agents, we will most likely use the predefined variables. That is a set of variables that specify the location where our code is stored, where we download our dependencies, and as well some specification about the agent itself and the build. So here we use our pipeline workspace variable to specify the NuGet packages path. Then how we can leverage the templates even more. If we will be running multiple applications, let's try to move our step to common repository where we will be feeding it with the variable set for each of the apps. So as you can see, I don't know if is it visible or not, but here we have folder for each of the app, and then common stages with CI steps and CD stage. And we define our variables from our variable template set at the beginning for each of the app. And we move our template back to the common repo. But how we can enhance it even more? I really like the idea of having a master repository for all of our automation, as we are dealing with multiple applications, multiple projects, and this will let you to have a clear history of the changes that you are working with, one place to address your templates from, and just a general better control over everything. So what am I doing here is just creating a reference in the code repo with the trigger on each of the branches, which is trigger, development, release, specify my repository as my DevOps repo, and then template the whole stage, which is set in my main repository up here. And then this template refers to a common task. So this way, we have the same steps for each of the applications that is referenced in each repo of it. OK, another step into right direction. We templated our flow. We have a set of variables stored in the different file, but here comes a task at the end, which is publish build artifact. This is a more specific thing to Azure DevOps pipelines as it is. So we can use the publish pipeline artifact, which is a younger brother of build artifact, and what it differs is the scope of the access of this artifact, which is a pipeline scope, and as well the techniques that we are saving and downloading, maintaining our files, which is just simply faster. If we don't need the publish build to some other resource, we can just keep it in the pipeline and then ship it from there. Great. As we are heading into the right direction, we publish our pipeline artifact at the end. So let's take care of our dependencies and ask if they're running away. As we are running our builds, we want to have the same outcome each build our agent run. So for downloading packages, we want to have the exact version, the exact resolve version that we want to download. And how to resolve it? The answer is simple. Use the log files and log your dependencies. So package.json will mostly, or package config will mostly describe your project with some metadata, some description, versioning, packages, and so on. But package.json is a direct snapshot of your dependencies that will tell the package manager what exactly versions to download and in which order. So thanks to that, we'll get our workflow more robust and faster on the same page. So how can we use such log files? There are custom comments to use in our build steps. So for example, for NPM, it will be CI command, and for the .NET, it will be logged mode. So thanks to that, we are saving multiple minutes on each build. Great. So we have a solid hand on our dependencies. And what we can do now with log files. Let's imagine this. We're running 20 builds a day. We're downloading the same dependencies over and over. Each step takes 2 minutes. So we're left with an hour build time that is non-useful in any of the ways. So how can we resolve it? The answer is simple, basically developing a caching mechanism for your pipelines. This comes with Microsoft-hosted build agents and GitHub runners as well. So, but you would ask me, but we have the fresh agent each of the time we run our jobs with fresh storage, fresh sets of tools, and so on. How we are able to pass our dependencies downloaded on one agent and then reference it in another one? The answer is cache artifacts, and let's get an overview how to get one of them. First and foremost, we need to lock down our dependencies. For .NET, we'll use the property group restore packages with log files set to true. Then during restore, we will have our package log files in place, which need to be checked into the repository. Then here is a simple example of the package log from the package log file. So we have the dependency, the requested result version, and the content hash, which is unique for each of the dependency. Then what we need to do is develop a cache task, and the overview of this task is as it is. First, we need to define the key, which we will be identifying our workflow. So here we provide nugget as a key, just simply a string, agent OS, and then packages log JSON files. We then define some additional prefixes to restore keys. Some where the main key is not hidden, we'll try to resolve it with those prefixes. So agent OS, NuGet, and then NuGet. And then we specify the path to our cache folder from where the cache will be stored. So here is a path to our NuGet packages that we already covered. At the end, we define the cache hit var, and it is basically just set to true when there is cache resolved on our pipeline. And how make this mechanism works, we need one more thing. So for the restore task, we need a condition that where the cache is resolved, we just simply skip this task in order to use the dependencies from our cache artifact. And then during the pipeline run, we can see something like this in the logs. So basically, we resolve to our key, which is NuGet, Windows, and then the hash created based on of those packages log files. And how such builds look from the beginning? At the first run, of course, there will be no cache hit, so the cache step will just simply run. Then we restore our dependencies, build our project, test it, so on. And at the post job task, we have a cache checkout, and where the cache artifact is created and available for the next run. The time that such artifact is available is 7 days, so it is basically a mechanism for the daily running pipelines. And then during the next run, our cache is resolved if there were no changes in the dependencies, in the hashes of the log files, and we can skip the restore tasks. And idea here is just simply, the bigger the cache, the more we can save on the build time, of course. And as already covered, we can also have a caching mechanism on our GitHub runners. So we can use actions cache save and cache restore. The same with path to our dependencies, and then specifying the key to hit our cache artifact. Great, so let's wrap up what we already covered. We have our CI pipeline with templated variables in different folders. We store them in the central repository of our DevOps automation scripts and so on. We have a template of our CI steps when we what we feed with our parameters. We have a cache step at the beginning to resolve our caching mechanism. Then we have a restore task with locked mode to base it on locked log files, which is using the private feed and so on. And we have a condition to skip the cache if the restored is true. So great, good job that we were able to do that. We can get a raise and so on. But this is not the end, of course. We have many more ways, many more things that we want to implement in our solutions. Branching, scanning, quality gates, different deployment types, building images instead of artifacts, and so on. Each of the approaches will differ from your methodology tech stack and also from your tier perspective and goals. But one thing that I want to leave you with is to be as transparent as you can with your developers and ops as well. Make them aware of the changes, make it as transparent as it could be, preach the DevOps mindset, not create another silos in the game. And yeah, that's all from my side. Thank you. It's time for Q&A.